Imagine for a moment, you're drifting through the vast emptiness of space, surrounded by a sea of stars. Everything is silent, peaceful. But then, ahead of you, a strange phenomenon comes into view. A monstrous, gaping void, darker than anything you've ever seen. You realize what it is, a black hole, the most mysterious and terrifying object in the universe. Its immense gravitational pull stretches and warps the very fabric of space-time, consuming everything in its path. Now, imagine something even stranger. What if, instead of being crushed into oblivion, you somehow passed through this black hole and emerged in an entirely new universe, one with different physical laws, new galaxies, maybe even alien civilizations? It sounds like science fiction, but some of the greatest minds in physics believe this might actually be possible. For decades, scientists have studied black holes, trying to unravel their secrets. We know they form when massive stars collapse, under their own gravity, creating regions of space where even light cannot escape. But what happens inside a black hole is one of the biggest mysteries in modern physics. Many believe that the singularity at its center is a dead end, where space, time, and the laws of physics break down. But what if that's not the case? What if a black hole's singularity isn't the end of the story, but rather a beginning? What if every black hole is a cosmic seed, giving birth to an entirely new universe? And if this is true, then could our own universe have been born from a black hole in another universe? This question shakes the very foundation of our understanding of reality. And if we find the answer, it might not only reveal the origins of our universe, but also hint at the existence of an infinite multiverse, where countless universes exist side by side, connected through the mysterious gateways of black holes. Let's dive into the science, the theories, and the mind-blowing possibilities behind one of the most intriguing ideas in modern physics, the mystery of black holes. To understand how a black hole could create a universe, we first need to break down what a black hole actually is. These cosmic monsters form when massive stars, at least 20 times the mass of our Sun, reach the end of their lives. When a star runs out of nuclear fuel, it no longer has the energy to fight against gravity, so it collapses under its own weight. If the collapsing core is heavy enough, it forms a singularity, a point in space where gravity is so strong that it crushes everything into an infinitely dense state. This singularity is surrounded by an invisible boundary known as the event horizon. Think of it as the ultimate point of no return. Once anything crosses it, escape is impossible. Not even light, the fastest thing in the universe, can break free. That's why black holes are, well, black. For years, scientists believed that anything falling into a black hole was simply lost forever, sucked into an abyss where time and space cease to exist. But then, something strange happened. Theoretical physics began to challenge this idea. Einstein's general theory of relativity, which describes how gravity bends space and time, predicts that singularities exist. However, singularities create a paradox. They represent a place where physics breaks down, meaning our current understanding of the universe simply stops working at these points. This is deeply troubling because it suggests that black holes contain information that we can never retrieve, breaking a fundamental rule in physics: information cannot be destroyed. Some physicists began to wonder, is there something beyond the singularity? If we could somehow go past it, could we find something unexpected? What if, instead of being crushed into nothingness, matter falling into a black hole is actually funneled into something new? This idea led to one of the most fascinating possibilities. Black holes might not be dead ends, but rather cosmic tunnels leading to entirely new universes. The black hole Big Bang connection. Here's where things get even stranger. The more physicists studied black holes, the more they realized that the conditions inside them seemed eerily similar to those present during the Big Bang, the event that created our universe. Think about it. The Big Bang started as an infinitely dense point, just like a black hole's singularity. Then suddenly it exploded outward, expanding into the vast universe we see today. But what if that explosion wasn't the absolute beginning of everything? What if it was just the birth of our universe, triggered by something even bigger? This led some scientists to propose a radical idea. Our universe itself might have been born from a black hole in another, larger universe. The logic goes like this. When a star collapses, it forms a singularity inside a black hole. That singularity compresses space and matter into an ultra-dense state. Instead of being destroyed, that matter could be ejected into a new bubble of space-time, a new universe, separate from our own. Astrophysicist Lee Smolin developed a theory called cosmological natural selection, which suggests that universes evolve much like living organisms. According to this idea, each black hole spawns a new universe inside it, and the laws of physics inside that universe are slightly different from the parent universe. Over time, universes that produce more black holes become the dominant ones. In the multiverse, much like evolution favors species that reproduce the most. If Smolin's theory is correct, that means our universe might have been born inside a black hole, and every black hole we see in our universe could be the seed of another universe with its own galaxies, stars, and even life. Think about the implications. If this is true, then black holes aren't just cosmic vacuum cleaners that suck everything in. They're cosmic wombs, giving birth to entire new realities. But is there any actual evidence to support this? And if this is true, could we, 1, day travel through a black hole to explore another universe? Or would the journey simply tear us apart? A universe inside a black hole. Theoretical evidence. As mind-bending as it sounds, the idea that black holes might create new universes isn't just wild speculation, it has real scientific foundations. Several theories, mathematical models, and observations hint that black holes could be cosmic bridges between different realities. But how would this actually work? What would a universe inside a black hole look like? And could we ever prove that this is happening? One of the strongest arguments for this theory comes from the similarities between black holes and the early universe. As we discussed, the conditions inside a black hole resemble those at the birth of our universe. Both involve a singularity where space and time become infinitely dense. But there's a crucial difference. While a black hole seems to pull everything inward, never to be seen again, the Big Bang did the opposite. It expanded outward, creating everything we see today. Some physicists, including Nikita Popowski, suggest that this isn't a contradiction at all. Instead, he proposes that when matter falls into a black hole, it doesn't collapse into nothingness. Instead, it gets funneled into a new region of space-time, creating a Big Bang in another universe. This means every black hole we see in our universe could be the beginning of a new cosmos, expanding beyond our reach, just like our universe may have expanded from a black hole in another reality. The Einstein-Rosen bridge, a cosmic tunnel if I. Black holes create new universes. How could this transfer of matter occur? One potential explanation lies in an idea called the Einstein-Rosen bridge, better known as a wormhole. In 1935, Albert Einstein and Nathan Rosen proposed that space-time could fold in on itself, creating shortcuts between distant parts of the universe. In theory, a wormhole could connect two regions of space-time or even two separate universes. Some physicists believe that the singularity inside a black hole could be connected to a white hole, a theoretical object that does the opposite of a black hole, constantly spitting out matter instead of swallowing it. If this is true, then what we think of as the Big Bang might not have been the true beginning of everything, but instead the exit of a wormhole connected to another universe's black hole. This would mean we are living inside the offspring of an older parent universe. This idea, while fascinating, comes with challenges. Wormholes are highly unstable, and most theories suggest they would collapse too quickly for anything to pass through. However, some researchers propose that exotic forms of matter, like negative energy, could stabilize a wormhole, allowing it to remain open. If such matter exists, then black holes could indeed be cosmic gateways, endlessly birthing new realities, quantum mechanics, and the black hole information. Paradox, another clue that black holes might be connected to new universes, comes from quantum mechanics, the strange science of the smallest particles. One of the biggest mysteries in physics is the black hole information paradox. Here's the problem. According to quantum mechanics, information in the universe can never be truly destroyed. If you burn a book, for example, its information still exists in the form of ashes, smoke, and heat. It's just rearranged. However, if something falls into a black hole, it appears to vanish completely, violating this fundamental law. Physicists like Stephen Hawking struggled with this paradox for decades. Hawking originally suggested that black holes slowly evaporate over time, releasing energy, but erasing the original information permanently. However, later theories propose a different solution. Instead of disappearing, the information that falls into a black hole could be encoded in a new universe, essentially creating a cosmic memory transfer between realities. This would mean that black holes don't destroy information at all. Instead, they rewrite it in a new space-time bubble, allowing a fresh universe to emerge with slightly altered physical laws. If this is true, then every universe in the multiverse could carry the genetic memory of its parent universe, passing on subtle changes with each new generation, just like evolution in biology. Can we ever prove this theory? Of course, all evolve. This raises an important question. Is there any way to test this? After all, if black holes are birthing new universes, those universes would be hidden from us, completely separated by the event horizon. So how could we ever confirm this theory? One possible clue lies in cosmic background radiation, the faint glow left over from the Big Bang. If our universe was born from a black hole, then we might find irregularities in this radiation, hinting that our cosmos is connected to another one. Some researchers have already detected strange patterns in the cosmic microwave background, which could be imprints from past black holes or wormhole tunnels. Another approach is to study black hole collisions. In 2015, scientists detected gravitational waves, ripples in space-time caused by two black holes merging. If black holes really do create universes, then these gravitational waves might carry subtle hints of physics from another reality. Future space telescopes and detectors, like the James Webb Space Telescope, could provide deeper insights into these hidden clues. But perhaps the biggest question of all is this: could we ever travel through a black hole and see what's on the other side? Is it possible that an advanced civilization, or even future humans, could harness the power of a black hole to enter a parallel universe? Or would the intense gravity simply crush anything that tried? Could we travel through a black hole? The ultimate cosmic journey so far, we've explored the mind-blowing possibility that black holes might give birth to new universes. But could we ever travel through one and see for ourselves? If black holes are wormhole-like tunnels to other realities, is there a way for us, or an advanced civilization, to survive the journey? At first glance, the answer seems to be a definite no. The gravity inside a black hole is so extreme that anything approaching it gets spaghettified, literally stretched into thin, elongated strands as it falls into the singularity. The tidal forces are so strong that even atoms get torn apart. So if we ever tried to enter a black hole, we wouldn't just die, we'd be shredded down to our subatomic particles. But there's a catch. Not all black holes are the same. Surviving. The fall. The role of supermassive black holes. Most of the black holes we've studied are stellar mass black holes, which form from collapsing stars. These have intense tidal forces near their event horizons, meaning anything that gets too close is doomed. However, the situation changes with supermassive black holes, the enormous monsters at the centers of galaxies, millions to billions of times the mass of our Sun. A supermassive black hole has such a large event horizon that the gravitational gradient is much gentler. In other words, you could cross the event horizon without immediately feeling anything strange. From your perspective, space would seem normal, until you realized you could never turn back. This means that if we wanted to explore a black hole, we'd have to target one of these giants, perhaps Sagittarius A, the supermassive black hole, at the heart of our Milky Way. But even if we could enter a black hole, that doesn't solve the problem of the singularity. Traditional physics suggests that space-time becomes infinitely curved inside a black hole, leading to an inevitable crushing point. However, some theories propose an alternative. Instead of a singularity, a black hole could contain a hidden doorway to another space-time region. quantum loop gravity, and the bounce universe. One of the most promising ideas comes from loop quantum gravity, which suggests that space-time isn't infinitely divisible. Instead, at an incredibly tiny scale, space is made up of discrete loops, preventing the formation of true singularities. In this model, when matter falls into a black hole, it doesn't collapse into an infinite point. Instead, it undergoes a quantum bounce, rebounding into a new space-time. If this is correct, then a black hole wouldn't end in destruction. It would act as a gateway to another reality. Some physicists believe that this could explain the birth of our own universe. Instead of emerging from absolute nothingness, the Big Bang could have been a bounce event, triggered by the collapse of a massive black hole in a previous cosmos. If this is true, then our own universe could be inside a black hole right now, completely unaware of its parent reality, the possibility of an escape route. So if black holes really are tunnels to new universes, could an advanced civilization ever harness them for interdimensional travel? One potential way would be to stabilize a wormhole using negative energy or exotic matter. If a civilization had access to this kind of technology, they might be able to create an artificial black hole, control its properties, and safely pass through it. Some theories even suggest that highly advanced beings, perhaps post-human or extraterrestrial civilizations, could have already done this. If black holes are cosmic gateways, they might be used by intelligent species to travel between universes, effectively making them portals to the multiverse. If this sounds like science fiction, remember? A century ago, black holes themselves were considered science fiction. Today we have real images of them, and we're only beginning to understand their mysteries. Final thoughts. Are we living in a black hole? As crazy as it sounds, some scientists believe that we might already be inside a black hole. The expanding nature of our universe, its early conditions, and the strange properties of quantum mechanics all seem to align with the idea that our cosmos could be the offspring of a much older universe. But if that's true, what's outside? Are we part of an infinite chain of realities, with universes constantly being born through black holes? Could our own black holes be giving birth to new realities right now? And most importantly, will we ever find a way to escape the limits of our own cosmic horizon and explore the multiverse? Maybe one day future explorers will step into the heart of a black hole and emerge on the other side, in a brand new reality. Until then, black holes remain the most mysterious and mind-bending objects in the cosmos, hiding secrets that could redefine our entire understanding of existence. What do you think? Could black holes really be creating new universes? And if so, will we ever prove it? Let me know your thoughts in the comments below. Don't forget to like, share, and subscribe for more mind-expanding content. Until next time, keep questioning the universe,